multiple tables, depends on the conditions that we wanted. So joins are like, there are different types of joins, right? Inner join, left join, right join, full outer join, cross join, and we also discussed self join. Okay, so that's what we discussed yesterday. And today we will discuss some advanced concept again. That is subqueries or correlated queries. Okay. So what is this first? What is a subquery or what is a correlated query? So subquery nothing but, so we add additional query that can be written in where class or from class or a select or join or having as well. Okay, right, we use where to filter the data and from to select anything from a table. So instead of a table, we can also write a subquery and select nothing but. So in select as well, in place of one of the columns, we can use subquery. And in the joins, so when we join the tables, maybe table A and table B, instead of any of the table, we can also use subquery. And having, so this will be used to filter the aggregates basically. Okay, so this is a subquery basically. Okay, that can be returned in all these classes, any of following classes. Okay, and then, so what are the different types? So basically we have two different types, correlated and non-correlated. Okay, so correlated, non-correlated. So basically when we write a query, right, I mean, in specific to subqueries, let me give you an example. Select star from employees where employee ID in select employee ID where from employees where job ID equals to AD PP. Okay, so here this is a query. Okay, and here this is outer query and this is inner query. And first this will be executed. Okay, and then for all these employee IDs that it returns, so it will check the condition where this employee ID exists in the list of employee IDs given by this subquery. Okay, so here what is correlated and what is not correlated? So this is not a correlated query because when there is a relationship in the outer query, this is the outer query. Okay, and which is I'm putting it as a all, okay, upper cases, and this is inner query. So both are independent here. So there is no link in this two, right? This is a non-correlated query. If I add a relationship between the outer and inner query, right, then it becomes, see, implies E and implies M. Okay, I'm saying E.job ID is equals to m.job ID. You see, now there is a relationship. So now this employee, right? Employee E and these are employee M. What I'm doing, I am comparing this employee's E, right? E dot job ID is equal to M dot job ID. Now there is a relationship established between outer query and inner query. Now this is called correlated query. Okay. So when the subquery is independent, that is non-correlated. If the subquery is dependent on the outer query, then this is correlated subquery. Okay. And now, so how the execution will happen in both cases? So in non-correlated query, first, so inner query will be executed, then outer query based on results of inner query, right? And how about correlated query? So now we have this relationship here, right? E dot job ID is equals to M dot job ID. For each of this record in the outer query, the inner query will execute. Each of the outer query record, outer query result, the inner query will be executed. So because we created a relationship between the outer query and the inner query. So if there are 100 records, this will be executed for 100 times. If there are 1 million records, they will be executed for 1 million times. Okay. And again, which is preferred? Correlated or uncorrelated? Anyone? Any guesses? So basically, this will be preferred most of the times. And if we use this correlated query, so if the table size is huge, performance is less. Performance concerns. Okay. And this can be achieved, we'll be using exists operator. Okay. And for correlated queries, we'll be using. See, this can be used, not only exists, so we can also use in, not in, any, or all. So we can also use them here. Okay. So mostly we use these operators in the where condition. See, this is a in, and we are checking. So in nothing but, let's say this will give a list of ADVP, maybe 2 or 3 employee IDs here, and the outer query, right? This one. It will check whether that given 2 employee ID records available in the employees table or not. So that is how this query will be executed. So I'll pause for a minute. Let me know for any questions. Any questions or no questions? Okay. So depends on the result that a subquery gives us, right? So we divide those into 2 types: scalar or single value or single row. Okay, single row output or a scalar result. Nothing but only single value is given as an output from a subquery. And this is multi-row. So multiple rows as a result. So how do we handle? So when we get a single value as an output from a subquery. So basically this is very simple. So we'll be using equal to or not equal to, less than or greater than or less than or equal to or greater than equal. Okay. So these operators we can use when there is a subquery that returns single value. Let me give you an example. I'll take this. Now, so if I wanted to find out all the employees whose salary is less than average of all the salaries. Okay, all the salaries in employees table. So now let's see, I'll modify this. Now, so what I'm saying, we need to find out the employees who are getting salary less than totals of average salary. I mean, all the employees average salary, right? So now how can we do that? So first, what we need to do? What we need to do first, I mean, to filter out salaries less than average of salary. Come on, guys, you need to tell me the answer. This is my question. Okay. So now you tell me, so how to find this? So maybe this is a question asked by interview. So how do you approach? No one, no idea, or you don't want to tell me the answer? Okay. So this is very simple. So what we need to do? So we need to break down into two things. So first, find all employees whose salary is less than average of salary of all employees in the table. First, we need to find out the average of salary of all employees in the table. So how do you find that? Come on, there is a function. So we can use average of salary from employees. Okay. This would give us the total average. I mean, whatever the average that we have for all salaries in the table. Now we have one part. What is the other part? So find all employees whose salary is less than average of salary, right? So now what I'll do, I'll write another query now. Select first name from employees. Okay. Where what we need to compare? The salary is less than. Okay. Where salary less than of this one. That's it. Okay. So we have this average salaries already calculated, and we need to find out all the salaries less than the average salary. That's it. Now we have these many employees who are getting less than of average salary. So even we can print salary. Absolutely fine, right? So what is the average salary basically? 6,400 something, right? And if I execute this, see all the salaries which are less than 6,000. Even we can, right? 6,460 is something that is average, and everything we got below the average. So now this is an example of scalar subquery, because this is giving us only one value or single value. That's why this kind of subqueries are called as scalar subquery or single value subquery. Any questions? So whenever we use this single value or scalar value subqueries, so we'll be using these operators, either of this one. Okay. So now here, right, we use this less than symbol, and maybe you can try it out with this one. Check, you can always use greater than as well, greater than or equal to, you will get more salaries than the average. Okay. And you can also use greater than or less than or equal to, anything that works. Okay. All right. So this is all about scalar subqueries. Any questions? Guys, you need to speak. You understand, you don't understand, you not answer the questions. It's not good. Right. Okay, so now we'll look at multi-row or multiple row subquery. Okay, so what is multiple row subquery? Okay, so now, let's say I'll do this way, select star from departments. Okay, see, I would like to print all the employees, okay, who are working for marketing and IT department. So department ID 20 and department ID 60. Okay, so my question is, find all employees who are working for marketing and IT departments, right? So how to find this? Can anyone tell me the approach? So now we have two tables, right? Employees table and departments table. Okay, and what we need to do first? So we need to filter out both departments, IT and marketing departments, from the department table, and then we need to filter out those department IDs from the employee table, right? Now what I'm doing, so I need to find out departments where department name in, so it is IT, comma, I'll copy paste it, marketing. See, we have two department IDs. Okay, we have Git. So again, so we need to find out the department ID, not everything. Let's see how this works. Okay, 20 and 60. We got it. So is this multiple row or a single row? So this is a multiple row. Now, if I use this, I mean, I'll write the outer query now. Select. So I'll say first name, comma, salary and hire rate. So just selecting some few columns from employees where department ID is equals to. Okay, this is my subquery now. And if I use this, there will be an error. Okay, what is this error? Can anyone guess? Come on, why we are getting this? Single row subquery returns more than one row. So basically, when you use this, it assumes this subquery is a scalar subquery or single row subquery, but it is not, right? It is giving us more than one row as a result. That is multi-row result. So if I use, in, this would work, right? We have these 7 employees who will be falling under department ID 10 or 60, which are corresponding to IT and marketing departments, right? So if you see single row subquery is giving more than one row, that thing, but your operator that you are using is incorrect. Okay. So we can also use not in as well. So we don't want to see those two departments. See, we got 99 records. And if you add those 8 records or something, so there is one record which doesn't have department as well. Okay, anyhow, this is how these queries will work, right? Are you getting it or not? Multi-row, single row subquery, multi-row subquery, and the error that we see, why we are getting that, everything.
Yeah, yes.
How about others? Others,
Yes.
are you listening? Are you sleeping? You are not talking. I don't know whether you are there or not. Okay, that's up to you, right? And now, so we also will see these two operators, all, any, or all. Okay. So now we were looking at single, this one, it is completed. This is a scalar or single value subquery. And now this is correlated. No, it's not a correlated. It is a multi-row subquery, and where we can use any or all operator as well. Okay. So if I use any, department ID less than any of this, I'm adding, I'll take, okay, less than any of this. And so I will also print department ID now. Sorry. Okay, so now I'm pinning this query and I'll just execute this subquery. So we have 20 and 60. This subquery will give us 20, 60. And now the actual query result is this. Okay. Now you see, this result already includes 20 as well. But exactly what is this and how it works? That's our question, right? So basically this any nothing but, so any will be used like this. I mean, this will be in combination of any of these operators that we mentioned here. and followed by any or all. So when I say any operator, so any one of the condition has to be true. Then all the results will be printed. So now what it will do, any nothing but, this query will be replaced this way. Any of 20, 60. So what does it mean? If the department ID is less than 20 or less than 60. So in case, the other way, it would be like less than 20 or department ID less than 60. This is how the query will be interpreted when we use with any. Okay. Any questions? How this query got executed and why we are seeing this result 20 is in the overall query. So basically any nothing but it is like or condition. So either of the value has to be compared and there has to be one of the values has to be true, not everything. But if I use all, okay, see the query, only one, that is department ID 10. So department ID 10 will be less than 20 and 60. That is the reason we see one record is the output. So all nothing but this one. The same. But all and any, so it's a way of handling these multi-row subqueries. All means whatever the result that you have, that will be in a AND logical operation. If you use any, that will be in a OR logical operation. Any questions? When to use any, when to use also. This is the way we can understand that. Okay. Okay, this is all good. There is one more concept called nested query. What is nested query? So basically, right? So here in this, I take this as an example. So within this parenthesis, right? This is subquery, right? So let me write this way. So now this is a subquery. And if there is a query that is within this subquery or some other query, right? So let's say where I'll just rewrite this to have a nested query. Let me see the model. What are the tables connected with employees? So I'll just write some query. So we have something called job history. Okay, so what I'll do is I will print employees details. whoever has some employee history. Okay, employee history, nothing but, so the employee ID should be existing in this job history table. So now I'll write this query now. So select department ID from job history. Okay. Now this is a subquery. Now what I'll do, I'll write one more outer query. Select department ID from departments where department ID in. Okay. ID in, select a department ID from job history. Okay. And then we have department ID here. So now we have how many queries are here? See, this is a outer query, this is a inner query, and this is a nested query. So queries within queries, queries within queries. So we can write in that way as well. But how the execution will happen? The innermost query will be executed first, and then the control will be goes out of the innermost, and then the next order, next order, next order, like that. Okay, now this will be executed first. Executed first, and this will be the second. And this is the last execution. Okay, so let's see the query result. Let me see. We have department IDs. Okay. Right. So this is how the query works with a nested query. So nested query, nothing but, so maybe it is within a subquery or within any other queries. So whatever it is. Okay. This is an example of nested query. This is nested, or it is present within a query, subquery basically. This is a outer query, this is an inner query, this is an innermost query, which is a nested one. Okay, any questions? So what we discussed so far, scalar subqueries or single row subquery. Okay, and we'll be using operators like this. Okay, so multiple row subqueries. So we'll be using in, not in, any, all operators. Okay, there is something called correlated queries. Okay, so we will be using exists operator. We'll see that now. So any questions? I will again pause for a minute. So let me know if you have any questions. No questions?
No, sir.
Okay. Now correlated queries. So what is correlated? So we just discussed, right? So I will give you an example again. Select star from employees where department ID exists. Select star from department. Okay. Where this, if I say this is a D, department's D, and this is employees E, I will create a relationship here. D dot department ID is equals to E dot department ID. So you see, this is employees table. Okay, and we have departments table. And you see if there are 106 records. And why 106? Basically, we have 107 records, right? Because we have one of the department ID value is null. This was not matched and it gave the result of 106 records. So what does it mean? This query will be executed for each value in employees table. This is correlated query. Okay. And again, so let's see one more thing. I'll keep it. Where salary less than any of this one. Okay. So what I'm doing is select average of salary from employees. Employees, I'm saying M as a alias, where E dot employee ID is equals to M dot employee ID. So now using no record. So I'll add one more thing, E dot and now we have 52 records. I'll make it as a very less. So first name, last name, last name. Let's say job ID. and salary. Okay, now I'll pin this result. Okay, and we have like almost 52 records, and we will verify how this worked. Okay, how this got executed, and we are seeing 52 records. Okay, now I will take, so select from employees. Okay, where job ID see, this is 5760, but what do we have here? What we did here? So for this IT program specific job ID, that group, the average salary is 5760, and we got the correct output. But if you take the other job ID, ST man, this is again, this is greater than 5760. But let's see what is the actual average of this. So you need to understand why we are doing this. So 7280. Now you tell me what happened during this query execution by looking at this result. Come on. This is a correlated query. Okay. Come on, guys. It's very simple to understand. Okay. Let me tell you what happened here is, for each of this job ID, right? It calculated average of that group. Okay, of that group, not single one. For each job ID that is available in the employees, where it is matching with the employees again. So any of these two would match because these are same tables, right? And this job ID, let's take it as a IT programmer. It will be taking average of the salary, okay, then comparing it here and giving us the result. So that is the reason if you take all the result that we see, the salary will be less than that of their corresponding group, less than salary of average salary of that corresponding group. So these are reasons, this is a reason. So it is not recommended to use correlated queries, because if you are doing this kind of calculations or manipulations in the data, and if the table size is huge, you will be unnecessarily wasting all the resources on the database server. Okay, this will impact the performance. Okay, any questions on this? Reddy, Rishi Reddy, Raghunath.
No questions.
I don't see you are talking today.
No question.
No questions. Okay. Okay. So we covered subqueries and correlated queries and some operators like in, not in, exists, any, and all, right? And now we have something called CTE. This is a called common table expression. Okay. And what is it and when to use this? Anyone know? I mean, CTE is in SQL. We are at the time, right? Maybe. So maybe we will talk this tomorrow. So it will take some time to explain. I don't want to extend the class today. So any questions?
No.
Okay. So again, so when where we can use this subqueries? Anyone? Where to use subqueries? So I'm just reiterating this. We can use this subqueries, okay, in select class, from class, where, and in the joins, okay, and as well as we can use them in having as well. The group by having, okay, you can filter the condition passing a subquery, okay, and then so for DML operations as well we can use when we update or delete records from a table. The conditions like, so whenever we are deleting something or updating something, there also we can use subqueries. These are all the places we can use, and you know, we cannot use, we can't use order by class in the subquery. Okay, so let me see if I can execute order by one. See, missing right parenthesis. If I remove this, executed. So basically, the order by class is not supported, but you can use group by. Simply, you know, group by job ID. That works. But order by is not supported in the subqueries. Okay. And let me having salary less than 5,000. Let me see if this works. Mostly no. Select so why I'm getting this error missing expression? So because this is a subquery, it must be enclosed in here. Group by having, and you know, this is a subquery, right? See, so this is an example of using subquery with having class. So likewise, you can try it out and the different ways that we can use these subqueries with these classes and update and delete. We will discuss this maybe tomorrow or day after tomorrow's class. This comes under DML operations. In the very first class, we discussed what is DDL, DML, DCL, and TCL and everything, right? If you can remember all those things, so you can relate these update and delete commands. Okay, so that's all for today. So let me know if you have any questions before we close this class. No questions? Okay, great. So see you in the next class. Bye.